Good morning.
Hello.
Hello, good morning.
Morning.
I'm here. I'm
Yeah.
here. Voila.
Hello. Good afternoon to everyone.
Good afternoon. I'm going to share the screen. So in the meantime, I see the moderators already here. So Rainer and Elena, and also I see the representative of the project. So in the meantime, if you want, you can go ahead. Please, the floor is yours, Rainer.
Thank you very much. My name is Rainer Bacher. I'm the moderator of this so-called parallel session 3. And I would like to welcome everybody in this session. This goes from until 12:10
Yes.
officially. Maybe we stop a little bit earlier. We have organized here hopefully an interesting interaction and discussion with you. This is about digitalization. This is the key motto which we look after during all these regional workshops. And today we try, well, we talk about digitalization of the energy system. We are fully open, but we try to focus, if possible, on two sub-parts of digitalization, which is digitalization around monitoring and control of the system and the parts and the components of the system, and also about interoperability. If we do not hit these 2 points fully, no problem. Digitalization is the key issue here, but let's try to learn about the two focus themes and conclude, what we need to do in terms of research, projects, and so on. This session starts with a short introduction, as I do it now. Then we will have 4 projects, which I welcome very much. I will introduce them later, or they will introduce themselves. They will give so-called 99-second pitches, which will very briefly introduce each of the 4 projects, which contribute to digitalization and to the focus themes. And we will discuss with them a few questions. And then as a third part, we will go into a so-called panel discussion with the projects and with some panelists, where we talk about what we heard, what needs to be done, where are the gaps, where are the problems, where are the trivial things, and just have really a learning. And the goal of this whole parallel session is to say that, as we said before in the session before, we are writing our regular key documents in ETIP SNET, and one is the implementation plan. And the next one, as you heard, will be out by the end of this year. We really try to write up in this implementation plan the needs which we learn at all occasions from our stakeholders, but also from the ongoing projects. So this is why we really try to interact with them, and we are very glad to have this opportunity here. So let me just go, and this session is actually co-moderated by Elena. She will introduce herself in a few seconds, and you already heard her actually in the session before with the last question. So let's go on, or I give you very briefly the word, Elena, and then let's go on, please.
No, I think you gave me a very good introduction. I think I introduced basically myself with the last philosophical question about who are we performing this digitalization and transformation for, bringing back focus from building European networks of collaboration down to the end consumers. But yes, my name is Elena Boško-Kovač. I come from an Austrian company, and I've been part of the working group of ETIP SNET, working group for digitalization and customer engagement since its inception. And it's been many years, and many interesting projects and many interesting participants have gone through and have been represented in some of our white papers. So without further ado, Rainer, let's go. Let's kick off this very interesting show. And I would very much invite everyone to listen to our panelists, and please shoot out all of the questions that you might have in the Teams chat. This is an opportunity to really dig deeper into the details.
Great, thank you very much. And I also liked very much what you said in the session before. You know, what are we talking here about? You know, is this about the consumer-related digitalization, or is it about the digitalization on the pan-European level? Well, in the end, we cover everything, but we want, of course, to go into the new areas, huh? And let's see, you know, what we can talk about. Let me give a few more words, and then we will give the word to the projects, and then let's openly discuss all issues. So we have four great projects in this session. You see them here on the screen. You see on the left-hand side where they are, who is representing them. This is Nathalie Grisi from France, RTE, Hans from Cirque, Monica from CICEA UPC, and Lazar from the Blueprint Energy Solutions. They will talk about their projects in a few seconds. Next slide, please. And sorry for this, for us, I guess, a trivial slide, but I just want to go very briefly, what do we want to hear about here? Huh? And the motivation starts actually from the European energy policy goals. You see them very aggregated here. It's the security, resilience, and the reliable supply as point one. Then we need to consider how much it costs. It should be affordable and market-based. And all this needs to be done without, let's say, endangering the environment and really getting CO2 at least neutral or even free, you know, by 2030, 2040, 2050. So this is what ETIP SNET tries to contribute. Next slide. And as said before, we have these key documents. Please, you can go into Google search or so, and you will find the links to them. They are under permanent revision, and as we said, at the end of this year you have the left side document, the so-called implementation plan, as a new edition for 2020 to 2022 to 2025. That will be our next one. And the roadmap, which you see in the middle, is the 10-year time frame. That one will be updated by the end of next year, at the end of 2022. And for now, the vision is still robust. We don't change the vision. Next slide, please. And here I just, as part of the introduction, Elena, please, you can say a few words.
Yes. As part of the introduction, I wanted to bring some awareness to an initiative of the European Commission recently, specifically focused on digitalization of energy. Some of you may be aware of it, but the Commission has been running a public consultation on digitalization of energy action plan and roadmap. And key importance of the working group 4 was in contributing a very structured analysis and feedback to the published consultation. So in order to give some context about it to the ones who are not aware, to meet the Green Deal objectives, thank you, Maria Laura, of the twin green and digital transition, the smart, integrated and cleaner energy system is needed. And there are several aspects, several components of this action plan. Unfortunately, I think the small print is too small here for you to read, but it is focusing on data sharing infrastructures. It is focusing on cybersecurity, on supporting the development of new platforms, interoperability. So there are multiple aspects of the publication in order for the Commission to reach the targeted digitalized energy system that is able to deliver all of the goals, such as new tools to manage the energy systems, more efficiency in the networks, new market participants, which is actually very hot topic, and we will see it, I believe, as part of some of the presentations, how to enable all of this flexibility in the networks, leveraging the digital tools. So in June this year, actually July, we have had a meeting with the Commission, and we have discussed not just these topics, but also what kind of benefits the digitalization will ultimately bring. That's all, I think, for this slide. And I would invite everyone to, let's say, if not, check out the public consultation as well.
Yeah, thank you. I can just hang in for the audience. This is also what ETIP SNET is asked. Tell us in words which the Commission and the governments understand and which they can translate into regulations and so on. What are you doing? What are the benefits? Why should we do it? Why should we invest? And this is what Elena just talked about, is one of the key activities also of ETIP SNET. It's giving advice to the European Commission, to the governments. We try to support them in the very challenging task, of running the system, of moving it forward. So what we are doing in these regional workshops, we have 8 sessions in this 3-year period. We are now in session number 3. As I said, we are talking about digitalization, and we try to focus on monitoring and control and on interoperability. And actually, you see also what we did before in regional workshop 1 and 2, and what we plan at this stage, and knowledge we have in the upcoming regional workshops. So we talk about other themes. You see them on the screen. And if you have an interesting project, if yourself in the audience, which may fit into one of these sessions around digitalization, please, send an email to us, and when the call for projects is out, just apply. We are very interested in hearing from you. Next slide. So this again is also small fonts. I'm sorry that those are not the slides which one should present, but anyway, it's just to give you an inspiration what ETIP SNET has been doing in the last implementation plan. We are trying to group the things to research, the issues which should be shown in projects, and we have created so-called topics. You see them on the left-hand side. We only look here at the digitalization topics. We have created 5 topics, 3.1, 3.2, 3.3, 3.4, and 3.5. You see how we define them. We will talk about them later. And on the right-hand side, you see that we even digged into each of these 5 topics, and we talk about so-called research tasks or tasks. And you see the list of tasks as we have defined them. And if we can learn from the ongoing projects, the ones which we hear now, a little bit about this or that aspect of these so-called tasks, it would be very helpful for us. We want to, ETIP SNET, when we write the implementation plan, we need to find out, are those the right subjects? Do you understand what we, ETIP SNET, meant by writing them down? Are they on the right level? Do we miss something, or are they already solved to a wide degree? So we will, but let's see how the panel discussion goes just a few minutes later. But I may ask you on these issues, on these tasks. Have you been dealing with these tasks? Have you been trying to solve them? How did you solve them? Those are a part of the interest which we are trying to dig here a little bit and to advance. Next slide. And again, without going into details, you see here for the other 3 topics of digitalization, what we have formulated as tasks on the right-hand side. You'll find big data management, risks. All these issues are explicitly mentioned in our IP, and please help us to reshape these tasks. If they are wrong, correct them. If they are right and solved, tell us. Or if we need to dig more and open new tasks, we also need to know. Next slide. So now I think I give the word to Mary. Can you lead us through 2 intro trivial slide questions?
Sure. Yes, sure. So it's the same exercise that we did first. You find the links in the chat. And I will launch the Slido, so we give you some seconds to click. Tell me.
Yeah, you must go to session 3 now, huh?
Yes, you have to go here up to up right, as you can see here on the screen. You have parallel session 3. So you can select it, and then you should see these questions. Let's wait some seconds. And the first question is, in which country is your company organization located? We did the same before, but now we are focused on the attendees of our parallel session.
And while you are typing, you know, this is really for us of interest, you know, who is going to the various sessions here, and we may, you know, learn something from it. And it's interesting to see who is represented. And if the font is big, you all know, then we get several answers from that, you know, typing that country.
At the moment, the majority is from Spain and France. So we have 16 participants to the Slido, but we are 29, excluding me, Rainer, and Elena. I don't know if you are participating. I'm not. We should have around 27, 26 replies. At the moment, now show you also someone from Ireland. So, but the majority is still Spain, France, and so we have Switzerland. Okay, I think Rainer, it's you, Switzerland.
I'm cheating here. No, I'm Switzerland. Yeah.
Slovakia, Belgium, Greece, UK, and Europe. Germany, Austria, Netherlands.
That's very good.
So 1 second. Okay, so 19 replied. The other 6 or 7 we'll do later. So this is was the first question, and now I stop it, and we should go to the next one. From which sector you are?
Yeah, we had comparing to what we had in the main session, again, research institutes at the lead. Less universities, as I remember the last time, but maybe yes. Well, less. It doesn't matter. We have quite many other, huh? Correct? Can you go up again?
Yes.
Yeah. I think we have consultants there and things like that. So that's probably what we need to refine more. But it's interesting. And technology providers, of course, you know, they are providing or intend to provide the digitalization solutions. So that's very good. But we also have distribution system operators.
Interesting. We have someone from ministry.
Okay, yeah, very good.
I'm actually quite curious about these polls, whether the research and innovation in Europe is truly driven to this extent by research institutes as key drivers, and how much do you think the industry drives this as well in parallel? Because we don't have many industry participants here, but as we will see during the presentations, and I'm sure as you're aware, a lot of technological providers and industry together with system operators are driving innovation as well. So a philosophical question as well. Who is really driving innovation? What kind of institutions, and how different are we, for example, from other continents and companies we are competing with as Europe?
Yeah, and they can hang in, not who is, but also who should drive. You know, in the end, we may conclude on things to update, to correct, or to change. Yeah. Anyway, we have the other, which I think are really probably a lot of consultants, and we also have the manufacturers in here. Let's go for the next one. Yeah.
Oh, yes. So the question is, which of the following are currently your primary research topics within digitalization?
Yeah, so we have the 5 topics of digitalization, as I mentioned them before. Just try to hit, I don't know if you can hit more than one, but you just hit 2.
I think so.
Try to hit 2 out of the 5, which are your primary topics. And that's the question to the audience.
We can only hit 1.
Okay, then please just take the highest one, even if it's not easy for you to say sometimes. Yeah. Yeah, that is, if I just spontaneously talk about it, it's quite an even distribution. That is interesting. Yes, cybersecurity gets nothing. That is interesting to see.
Yes.
Data communication acquisition, which actually a smart meter is a keyword of today, is not very high. Interesting. And what is high is yes, the standardization, the models, the platforms, I guess. Yeah, 1 and 2 are strongly linked together. Okay, that's for me an interesting indication what type of audience we have. If you want to add, Elena, feel free.
No, nothing to add. It's very interesting for me to see that, let's say, profiling a workshop this time on monitoring, control, and semantic interoperability excludes interest of people who have strong, I would say, opinions and capabilities when it comes to cybersecurity. Because for me, it is not separate from interoperability and monitoring and control issues. So very interesting to see. It's a big gap that is reflected in the market too.
Yeah, very good. Okay, but I think now we got at least one vote or 7% in the cybersecurity. And we are all aware, you know, it's not so easy to set the priority. It means we do other things. But anyway, very good. Thank you very much.
The next question
yes.
is this is in order to overcome obstacles in creating digitalized, decarbonized Europe energy networks, are we lagging more in competitive technology development or legislation?
Yeah, and just think before you give the answer. You can challenge us, and you know, but yeah, just tick. And if you don't know, you can also go to other. Well, not don't know. If you have another one, tick other.
At the moment is 67% the right legislation, and okay, well, 60-40 innovation and in technology and their integration.
Yeah. The only thing I can say for now, this is really, again, interesting. This question was provoked by Elena, actually. And I think I feel, you know, it is, when we heard what we talked about in the last session, it is really this dilemma between, what rules do we need to achieve, so that we can achieve the good technological solutions, you know, and Elena also said it, how can we remove the complexity from the consumer? And is this really research in technology, or is this more the right rule set, which may be the legislation? Anyway, it's nice. Yes.
Rainer, I'm curious to know this 7%. If people that reply that tick this other, maybe could write which one are in the chat, so we can also extend a bit more.
Okay. Yes. Use the chat, the Teams chat. To just
yeah.
There is a response and it's on point. It's the change management. So there was a response in the chat.
Yes, change management. Yes,
and organizational adoption. I think this is really crucial. It's again partially associated how to take away the complexity from the sometimes end customers. But what do you do when you want to implement these new shiny complex tools for network management, for analytics? How do you actually utilize the tools and train staff in the organization for proper decision making? And I absolutely agree that organizational change management is a big part of it, because again, resources are at the heart of this transformation.
Yeah, very nice. Thanks, Laura, for your input here. Very good. Let's go on. You can put up the slides again, and I think we are.
You see them?
Not yet. No.
Okay, weird, because I see them. 1 second. I try again. Sometimes the mystery of Teams for me still after 1 year and a half, but okay. You continue to don't see them?
No, I don't see them right now.
Also can't see them.
Sorry for this.
No problem. Now it's changing. Yeah.
I think it's coming.
It's on.
Very good. Okay.
Yes. Then I can back to the slide. Okay. think we did it.
That is fine, and that is fine too. Let's go on here. Next one.
Voilà.
And okay, so now we are ready. Well, we have been ready before, but now let's go for the project pitches. And I ask each of the four, starting with the Osmose project. Natalie, can you show your few slides in exactly 99 seconds, please?
So thank you, Rainer. So I'm Nathalie Griset, and I work for RT, the French TSO, and I'm the coordinator of the Osmose project. So one topic we are covering in Osmose is the demonstration of grid forming control. So I think you may wonder what is grid forming. So basically, it's a new control to be implemented in inverters, because with energy transition, we have basically synchronous generators, which are more and more replaced by inverters-based generation. And basically, if we don't adapt the controls of this inverter-based generation, we may have problems because it will reduce the power system stability. And so grid forming, so it is necessary for stability of the system, and thus it is a local and extremely fast control because it should act in less than 200 milliseconds. In our project, we have worked on 2 demonstrators based on battery energy storage systems, each over 1 megawatt. You can see them on the slide. So next slide, please. So our main contribution was to successfully implemented grid forming controls on those 2 demonstrators. And more precisely, we have translated functional specification into technical requirements that are suitable for grid codes and applicable for control design. And we have also worked on the monitoring, basically, and definition of compliant tests and criteria to assess this new functionality, which is grid forming. And so we hope this contribution paved the way, actually, for grid forming control to become a standard control for inverters connected to the grid. On a very different topic, Osmose has also contributed. No, please come back. I'm not finished yet. So Osmose has also contributed to another topic related to the interoperability in substations, between equipment of substations, because we have demonstrated an interoperable IEC 61850 engineering process, which is based basically on machine-readable file for configuration and specification. And I'm done. Thank you.
Very good. Thank you very much. Let's do it the following way. Thanks a lot for staying in time here. It's really the 99 seconds are symbolic, but it shouldn't be too long. That was perfect here, what you did. Let's just ask two or three questions. When I hear, so this is for grid operators, correct? The grid operators are the buyers, in quote, of what you are doing here. Is that correct? It's not for consumers. It's not for consumers. Yes. It's not for generators. It's for grid operators. Mainly DSOs, distribution, or who is the buyer, in quote.
Yeah, so somehow it's for everybody because the stability of the system, for example, is for everybody connected to the system. But yes, you're right. It's more for it's a requirements for a transmission that transmission system operators could require for generators connected to the grid, basically. So far, it's not something which is buy exactly, because probably it's more something like a technical requirement. That's something that you really buy. It's like that's what we have in mind for the grid forming part. And on the part about the interoperable engineering process that for IEC 61850, basically it's a common work for transmission system operators, also distribution system operators and vendors of equipments, because the idea is to facilitate the exchange between the two when system operators are designing new substations. What we have worked on is an efficient engineering process so that the system operators can really specify what they need, and vendors of equipment can easily answer the specification, and so it's a smoother process for everybody. That's the point.
Elena, question or so spontaneously?
Well, it's quite a sizable project from what I see. It's 27 million funding. So who really truly benefits the most from this project?
So the main leaders of the project. Of course, we have very different partners in the project, as you may imagine, but so the lead is by RT, so TSO, and we have other TSOs involved in the project. So it's more on, let's say, services or functionalities for a system operation from a transmission system perspective. So it's not, for example, we have nothing with the consumer or really end users. It's not within the project. It's more on the very high system perspective.
But certainly something to build on, yeah, for the other stakeholders. Excellent.
Yes. Basically, what we, for example, we are defining some needs for the system to operate efficiently, and then for stakeholders like equipment manufacturers, we provide some recommendations on how to implement the different things that are needed for the system, so that they can anticipate the need. For example, what will be required in the grid codes. So I think that's the benefit for them is also by listening to what we are doing to learn more on what will come next in the future power system for people connecting to the transmission grid, at least.
Thank you.
Just one very short question on the TRL, the technology readiness level. I'm sure you're aware. Where would you position it? You know, we try to characterize project needs on that level. Where are you between 1 and 10? Where are you?
Well, I don't remember the exact rate,
yeah,
but we are quite
or
high.
describe it. Or describe it.
So because for grid forming, for example, we are coming now to some transmission system operators are asking wind parks connecting now to the system. I think it's in Germany to provide this control. So now it's coming really to the market position, and that's what we demonstrated in the project also, because we had vendors, and so they were able really to implement those controls in their really off-the-shelf equipment. So the TRL is very high now.
Very good. Thank you very much. Let's go to the second project, and then let's come back in the panel potentially. The second project is called Interpreter and presented by Hans. Please, Hans.
Yes, thank you. I'm Hans Blutzowait. I'm from the SILSE Foundation, situated in Spain. It's a technology center in Zaragoza. And we are coordinating a small, nice project called Interpreter. It's 5 million budget, 3 years duration. We are like 1 year away from the end. We are 9 partners from 6 countries, and we have 3 pilots, one in Spain, one in Belgium, and one in Denmark. Our child is a platform. It is called Interpreter Core Platform, which connects data from the pilots, from the infrastructure with data services. And in the middle, we have here the grid modeling tool, which is providing the grid model. Next slide, please. So that is an overview just to support the discussion later on. What are the services which we are developing in the project? In the middle, the grid modeling tools is the enabler to provide a grid modeling, a grid model from available data, which can be quite diverse and with different data availability levels. So we have 10 plus 1 data services. As a grid modeling tool, it's a service by itself. And then we have non-technical losses, ancillary service on DSO level, optimal grid control and safe healing, predictive maintenance. So also something about DSO, TSO interconnection. Then that was grid operation and maintenance. And on grid planning, we have optimal reactive power compensation, nodal capacity, optimal dispersed storage location, plant phase balancing, and LCC-LCA analysis, which is cross-cutting, giving some idea on the solution, on the impact life cycle analysis. And our main challenge here is data availability, which includes data quality also. That was it all.
Thank you very much. Can you just go? Yeah, just leave that, please. Just one question. Is this actually an implementation project or a research project? What is it exactly? Just to understand.
Good question. Yes, it is officially a research project, but our goal is to get to TRL 6.
Okay.
More or less, already quite close, quite high, and it depends on the different tools. There are some which are much more advanced, and others which are starting. For example, the grid modeling tool is assuming different levels of data availability. And of course, the more data you have, it's easier to create a model. And the less advanced part is the low data availability scenario, which we might need still another project to get that actually done. That it can be sold, let's say.
Thank you. Elena?
A question. Yes, I'm quite. This is, if I understand correctly, mostly again oriented towards distribution grid operators, correct?
Exactly.
Yes. So as such, I'm not familiar with the pilot sites and what they have, actually, what available technologies they already have. Some of these tools you can often find, or at least some of these functionalities you can often find in commercial systems that perhaps the company implemented. Maybe they already have, let's say, some of the grid control and self-healing abilities implemented in ADMS. Maybe they already have plant phase balancing implemented somewhere else, or optimal dispersed storage and generation. So how do you mitigate that? I would assume that interoperability of the design here comes into place. How do you manage that? And what were the challenges with obtaining the data, if any?
Yeah. Could we go to the first slide? I didn't mention in our Fuse platform we create what is called the data lake. So what we are showcasing is the fact that when we want to use the data, we need to transform the data to a unified format. We're here looking into the transmission system operator format. I have to get to the CGMES SIM format, and also of course the distribution system operators have their databases, their own formats, their own way to store data. So we need some adapters, some translators. So the idea is that this translator or adapter needs to be done, and once this happened, the different data services can be used on this. So yeah, we had also the question. Yeah, that these.
For me, it's actually quite. I'm personally interested in what is more challenging: obtaining data from a third-party vendor when you want to integrate, or is it more challenging when you are obtaining data directly from your pilot site, but it's poor quality? I think it's a running question for everybody involved in research projects, but just your experience, if you can comment on it.
Yeah, the idea here is that the service, when the DSO wants a service, it's providing its own data for its own use. So there, okay, there may be the service provider is a third party, but will not share the data with others. So there, in this sense, this is not so challenging. But of course, the data availability at the DSO level is very dispersed. For example, in Germany, there are no smart meters installed yet. In Spain, we have almost 100% coverage, which is because it's obligatory. So there's a big difference on that availability. So our idea is if you do not have smart meters installed, yeah, this is not feasible. You need some data to play with.
A very brief remark. It seems like you gave internals of the question which we asked before. Is digitalization also about rules, legislation, or is it about the technology? And I think you say we need the right rules everywhere in a certain way, you know, then we have, so of course, third parties, you know, do they have to give out the data or not? This is not really research, I think, to solve that challenge. It's a rule set, which we need to know what is allowed, what not, what is in the market. And the poor quality of the data, yeah, this is also probably a rule set where we simply need rules on the data quality, you know. So and if there are rules, let's say on a certain level, then the smart meter should be there in order to provide the right quality. But anyway, so
Can I add
this is,
something?
yeah, please,
Yes,
just very briefly, yeah.
Yeah, interesting remark. But just what I said, in Spain we have the smart meters because there was a rule.
Yeah, exactly. Well, but there's a European rule. Actually, everybody has to do it, but maybe it takes longer in some parts.
Yeah, but now
Europe,
the DSOs are discovering that it is really useful to have smart meters for doing many things.
Yeah. Okay. Very good. Thank you very much. Let's go to the third project, which is BD4OPEM. It's presented by Monica. Please, Monica.
Okay, thank you. So, my name is Monica Aragüez. I am lecturer at UPC and I am a researcher at TITSEA. I am the project coordinator of Big Data for Open Innovation Energy Marketplace. So to understand what we are doing in this project, let's contextualize it in the frame of the power system evolution marked by the 3Ds, decarbonization, decentralization, and digitalization. In this context, we can see that large amounts of data are available, but they are not always used and they are quite often underused. And artificial intelligence techniques have the potential to help extracting value from this data and to support the decision-making process for enhancing the power system operation. Okay. In particular, our project focuses on the distribution and consumption domains and relies on data from different sources, among them smart meters, which are key for permitting this transformation from traditional power systems into smart power systems. The objectives of our project, which can be seen in the next slide, can be summarized if we can go to the next slide. They are mainly basically the creation of an energy marketplace, and this is based on the development of an analytic toolbox. I don't know if you can move to the next slide, because I cannot see it. Thank you. Okay, so the idea is to create an analytic toolbox that serves as interface between data providers and data analysts. Data providers are those that have access to data, and data analysts will be processing this data in order to improve the monitoring, operation, maintenance, and planning of electrical distribution grids. So basically, we will be offering services which are, but not limited to, congestion identification, topology identification, energy management systems offering, also fraud detection, V2G services, among others. So thank you for your attention, and I will be pleased to answer any questions.
Thank you very much. Elena, please. I think your microphone is not on yet.
Now it's on. Thank you
Perfect.
very much. So yes, a very interesting project, very nicely structured, as I can see. I'm very curious about where are you right now in terms of different services? What kind of different services? Can you shed more light on the data analyst structure there? Give maybe more examples about what is being offered and who are these new users, if any, that are benefiting from your platform. Are there any users and new services created as part of innovation?
Okay, so thank you for your question. So basically, there are many partners being involved in the development of services. Some are being involved in the development of the algorithms that are running for enabling these services. These services include actions that are more focused on operation and maintenance. For instance, fraud detection, which is something which is very interesting for some distribution system operators, as non-technical losses can be important in their grids, and this can impact economically their business. We offer also services oriented towards grid planning. At the end, electrical grids are evolving. Generation and demand are changing in the future horizon. So we need forecasting tools to envisage which are these newer scenarios and how this can influence the actions to take or the reinforcements in the electrical grids. These reinforcements can be based on traditional actions like installing transformers, cables, lines, or can benefit from the flexibility inherent in these distribution grids. So we are also looking at flexibility estimation in this sense, and also for distribution grid and BRP services. So these are some examples. In fact, we have a large number of services, and probably for time constraints, I cannot mention all them. We are also looking at predictive maintenance, also at congestion identification based on or looking at which is the probability of having a congestion on the electrical grid, and doing so not using electrical specialized software, but machine learning techniques. And regarding your question on who are the users, the main beneficiary of this service is a DSO. Nevertheless, some of these services can be interconnected between each other, and the output of some of them can be an input for others. So imagine that you are a service developer, that you don't have the expertise to develop something which you require to pre-process your data, and that is needed to enable another service. You can be contracting a service that is developed by another entity so as to later use this as input for developing the service where you have the expertise.
Thank you.
Yeah. Just one, you mentioned here the Open Data Initiative, and is this an open source project which can be used by everybody, or how is that? Can you say something about that?
Not exactly open source. This is not exactly open source, because you know that there is this sensitivity of data. So let's say that obviously there are some parts of the project that will be accessible. Some parts, some deliverables are public. Some results will be shared, but not the whole. The developments can be open access. Okay. The idea is that part of the data or some data, if properly processed and agreed within partners, could be recyclable or reusable, maybe for other projects. But it's not the whole is open access. It cannot be, not everything can be open source, although there would be some benefits, obviously, for others. Yes.
Yeah, because I'm really, it was mentioned before, we want to reuse project results and learn together, and in the end achieve this energy transition to the CO2 neutral system. And it's clear to all of us, if we share more, then probably we advance faster if we don't need to reinvent it at every location. But I totally understand your answer. We have a few challenges here. It's probably not research challenges. It's again rule sets, What do you have to do with project results? How free are you? Is this an internal license? It's about IPRs and things like that.
Exactly. So this is a very important question, and it also affects the agreements within the whole consortium. And probably we will have more light on this at the end of the project. And currently we are practically on the half.
Yeah, and Okay, very good. We can talk about that. That is, to me, a fascinating issue. You know, when we talk about projects and what they do, and what is the maximum learning we can get out for the whole community listening and for others? And I still believe open source would be an issue, which is a hot issue today and not fully yet solved. Huh? So let's go to thank you very much for this very interesting project and presentation. Let's go to the last one. To XFlex, presented by Lazar, please.
Hello, can you hear me?
Yes, perfect.
Okay, yeah, my name is Lazar Miletic and I am working as project assistant at Blueprint Energy Solution, and today I will present the XFlex project. XFlex project has been founded by European Commission Horizon 2020 project. It gathers 12 partners from 6 EU countries. XFlex proposes a set of efficient, cost-effective and integrated solution that will facilitate the optimum combination of decentralized flexibility assets both on the generation and on demand side, enabling all parties, including final prosumers, to offer the flexibility, creating benefits to all the actors in the smart grid value chain. For the project proposed, XFlex developed 4 complementary products that will offer services to all the energy stakeholders, from network operators to final consumers, prosumers, and flexibility providers, including other intermediate players such as retailers and aggregators. Please, next slide. Yeah, XFlex platform. XFlex interoperability is the main pillar of the XFlex platform, and XFlex platform integrates all the XFlex solution in order to provide services for all the energy actors and ensure more secure, stable, and clean energy supply to enable local electricity marketplace, leveraging flexibility assets. It will provide a high performance and reliable middleware that will integrate and serve as a service bus for all the subsystem services and actors of the XFlex project. Different systems that participate in XFlex project and exchange data through the XFlex platform could be grouped in 3 categories. First one is XFlex flexibility and monitoring assets. XFlex tool, as I already mentioned before, 3 tools, actually the 4 tools, 3 tools in 1 platform. And at the end, the horizontal modules comprises a set of services for communication and analysis of data. And regarding the main elements of the architecture of the platform, a platform consists of data management integration interface, data management systems, internal and horizontal modules, support layer and user interface for all stakeholders, interoperability elements, and in the end, the XFlex tools, which are interconnected with ORS.
Thank you very much. Elena, shall I start, or how do you want?
Well, if you can go back to the previous slide,
yes,
I'm actually, you spoke, Lazar, a lot about the platform, but I see tools labeled as MarketFlex, ServiFlex, GridFlex, implying that there are quite different stakeholders using these different modules. Could you shed some light a little bit on who's using what, so that we get the context also behind the tools?
Okay, I will first start with ServiFlex. On the left side, ServiFlex is a tool for flexibility manager. Its main functionality is the analysis and forecasting of flexibility provided by flexibility sources such as generation assets, battery system, power to heat, and power to vehicle.
So aggregators in a nutshell, yeah, mainly, but
yes. GridFlex tool is the microgrid and the grid operator, and it aims to promote the monitoring through the integration of data sources such as SCADA system and SLAM systems. And at the end, the MarketFlex tools is the tool for the all market participant, and will facilitate access and the participation of the energy grid participation on the new market, actually on the new established market, on the projects such as a flexibility market and flexibility market and local electricity market, and ancillary service for TSO and DSO who can also participate in that, and also for aggregators.
Mm-hmm. Very interesting, thanks. Let me just ask you a similar question to the one before. It seems again like a very advanced or mature what you're talking about. Is this already on the implementation plan? Are we very near to a product sales here? Oh, can you go forward, please? I think we see the wrong slide here. But you can still answer, you know, what is the TRL level here, or is this research, or is this doing things? What is new? What is totally hard to do? That would be very interesting to hear.
Yes, regarding the TRL level, the platform is already in development of version 1 phase. So we are trying to achieve TRL level 6. So I want to highlight that the platform is not already tested at the pilot sites, and we don't have results yet. But in the next year, it will be tested. So all field assets and pilot sites are already for testing and for implementation. But due to the COVID last years, we had actually the pilot sites had some problems with integration new flexibility assets in the pilot sites.
Okay, and that is my other question. You know, we try to focus a little bit on monitoring and control and interoperability. I think when I hear the 4 presentations now, and this is a lot of dealing with each other. It means, you know, they need to talk to each other. It must be interoperable. These aspects must be in there. It's not so easy as a listener to get out what are the elements of interoperability which are key. But I want to ask you more on the other side, the monitoring. I mean, is monitoring simply a job just to do? You buy the products from whoever and you put them into the system and then you get the data, or is this still is the bandwidth a problem, or what? You know, that's actually what I also wanted to ask the other projects, you know. But can you what about monitoring here? Where does this happen? Is this a simple job, or is it open or challenging, or where are the problems?
No, regarding the monitoring and the interoperability, the platform is based on 6 data models, which covers monitoring and interoperability, such as CAI models, IAC 61850, SAREF, and OCPP model, and also we have yes.
Yeah, but that's okay. Yeah, no. And when you and the technology for monitoring, just to ask you a stupid question, sorry, is this an issue? What do you take? I mean, I don't need product names here, but is this? Do you have hundreds of selections, or you just know what to do, or do you stay conform to what you had in the past, or how do you do that?
No. The platform regarding the monitoring of, if you think regarding the assets, right?
Yeah, exactly. How do you go to the assets, concrete physical assets, or whatever it is?
Yes, regarding the assets, all pilot sites have a different architecture of monitoring their assets, and the platforms enable interoperability for all pilot sites to send data to the platform through the using communications standards and protocols, such as NAT and Kafka, for example, Apache Kafka, and we have MQTT protocols also for sending communication. And each of these tools communicate with each other with different communication protocols. So I want to say that we have a lot of communication protocols in data models who can communicate with each other through the message broker. We have the 2 message broker who is responsible for the sharing data, for the sharing communication data to between the assets and the tools. So in this way, is the monitoring is covered with on the platform.
I understand. Yeah, that's a very, very interesting answer. The issue is really interoperability in the end, you know, so that the physical access to the assets, you leave that to the past, whatever they have, this needs to be upgraded. It's not a research topic in itself or so, but that how do you get the things together? You know, this is the key issue.
Yes, with a lot of data models, different data models, and a lot of communications protocol who can interact with each other. So it would be how to say the simplest question for explanation.
Yeah, and just a remark also to our to our listeners. Each of these projects is, funded by institutions, and they have requirements on the deliverables, and typically the deliverables are partially, at least, public. Huh? So I'm sure we can also read some of the deliverables of the XFlex platform on the internet. Correct?
Yes, right. If you would like to read more about the XFlex platform, you should read the deliverables under work package 6, which is more specific for the platform implementation. Yeah, and the last one was 6.3, who describe the version 1 of platform implementation and integration with all different tools. So, for example, Marketplace, GridFlex, and so on.
I see you are actually halfway through the project. So I'm assuming you're going to have more public deliverables in that respect towards, I would say, the end or in the next phases of the project. Am I correct in terms of referring the audience to the website? Or we are anyway going to take a look, but you are halfway through, correct?
Yes, right.
Yeah, and that's thanks, Elena, also for mentioning that. We have ongoing projects, finished projects, and please, apply for showing where you are. The audience is interested. We are interested, and
Okay.
I think between the lines we are learning all together. I think. Very good, Elena. What's the next step here now?
The next step is
or Mary. Yeah, Mary.
No, Mary is actually the right person to introduce the next.
Well, we already did that. Okay,
yeah,
so
we already did the slide, so we already
that.
know the replies.
Yeah, but can I just leave it on again? My thoughts on that is it's really a very, very relevant question. I also liked the other, the third dimension actually, which is about change and what happens in companies and how to adapt. That's very important. And when we doing and I just give you the word, Elena, for the panel discussion. But this is. We are trying to find out where do we need to dig more with you? Where do we need more insights? How do we communicate these new insights? And we heard a lot about these projects. I think they all, they share very many interesting issues. But the rule set which we need, we just mentioned we need it, but we don't say exactly what. And we don't talk political actually. I think we are talking more technical, which is our foundation. But anyway, that's an observation which we may need to think about. Do we need to give new messages? Anyway, Elena, I give you the word.
So I would actually like to use the most out of the next, let's say, half an hour that we have.
15 minutes. 15 minutes only. Yeah, we don't have too much.
No, we have until 12:10. So
yeah,
we have 25 minutes to go.
I believe where everyone can benefit the most is stirring more questions towards the presenters here. I think we have very, very interesting projects presented. And we have prepared some of the questions here in the coming slides. Of course, we have asked some of them during the follow-up to each presentation, but given the type of audience that we have, given the number of people who have been listening here, I would truly like to invite you to start posting your questions so that not just ours, because Rainer and I have been talking a lot, asking a lot during the panel discussion today. Ask your own questions too. Some of you might be preparing for the incoming Horizon calls, preparing maybe some research and innovation projects. And as Rainer said, the vast amount of data, vast amount of research is there, but often you don't have the opportunity to hear and ask. As part of the state-of-the-art analysis, maybe you're already investigating some of these things. So let's use the time and ask the questions to the live presenters here. And I would like to, while we are waiting for your inputs, ask the first question here, which is, in your research and innovation project, what elements of these tasks did your project notice as some that are easy and have already been solved to some extent. Rainer, you were asking this question to some extent to the last XFlex project, I believe. And what other updates are needed for these topics and tasks? What challenges, what related themes need to come first? So a question to the panelists. I don't know if one of you wants to start answering this question. Should we invite perhaps some of the earlier or some of the first presenters in our panel session with this question? So,
yeah, you have seen these tasks before, which we, formalized in our implementation plan. That's what we say needs to be researched and shown in projects. I don't know if you have read the task list. What is missing? Where are the key priorities? Just say it out of your head. Where do we need to invest more to find out what we need to do in terms of digitalization, potentially with a focus on the two focus themes. There is one hand up.
Yes, it's from Natalie. Natalie, you can take the floor.
Yeah, thank you. So I'm not sure to which task it's related exactly, but it's related to the very topic of the session, which is monitoring. So I want to highlight that as a transmission system operator, where we are faced when we have new services provided by flexibility providers, we are faced with the question of how to monitor, because people are proposing new services, and sometimes it's not very easy for us to monitor it. And if we cannot monitor it, how to assess that it is effectively done, how to assess that it is very efficient, and so on. And that was a key question that we addressed in the project for grid farming, as I discussed it in my presentation. But it's a wider topic, actually. For example, to give you an example, we have currently more and more storage systems connected to the grid, and they are providing different services, because the more service they provide to the grid, the more economic income they have. So it's normal and it's good for everybody. But then it is difficult for us, for example, to see, to discriminate between the different services that are provided, to really measure it and to assess what is exactly done. And so it's not, let's say, it's not. I think it's a research topic. It's not extremely complicated, but sometimes it's not considered when in the different projects. So that's a question we have as transmission system operators, at least.
Yeah, no, I made a note of that. Very interesting. Yeah, thanks.
And then perhaps someone more focused on the distribution system operator from the project presented, Hans perhaps, or Monica. Maybe you can elaborate further.
Yes, and on our list to what comes next is on one side the sector coupling to have. I think it's another hot topic, but I think you have it already. To see how to integrate the thermal part. Although I am an electric engineer, and I think in the end we will electrify almost everything. And even natural gas produces CO2. So, or we get to the green hydrogen, or also the heat sector will be electric by heat pumps, for example. That's my vision. So, so our electrics model will be good to a certain extent, but we have to include the thermal models, the thermal inertia of we have as a storage in our system. And the other hand is coming to an online system. What our project is doing is offline, taking the data. Even if you are talking about operation and maintenance, it is looking to the past and thinking how we should react. But the real-time digital twin, that's the next step.
Yeah. Very good. Just to hang in here, sector coupling, I can tell you and the audience will be very high up in the next IP, also in this IP already, in the current one, but it will be clearly be increased in terms of importance. And the role of the electricity, ETIP SNET is saying it in the following way. We think of an integrated energy system, you know, a system of energy systems with electricity as its backbone. That's the way we say it, huh? Which doesn't mean everything is electricity. That would give really the wrong picture, especially on the local level, you know, where we have heat. But and also the question of gas as storage, be it green gas or whatever type of CO2 neutral gases, that's open too. That's how systems come together. And we think we are not yet fully fit for answering this system of system questions. And that's where we need more projects and research and so on. Yeah. And the real-time aspect, I just want to hang in, Hans, on your wish and remark. In a certain way, we had the other project, it was the first one, which talked about 200 millisecond controls. That was the osmose. What do you say to that? Did you already solve all the problems Hans wants to solve? Intends to solve, to be a little bit provocative, and I know the answer, but just so that we get projects to listen to each other. Haven't you solved all the real-time issues already in the osmose project? That's a question to Natalie.
To me, I'm sorry. No, for sure not. We have not answered all the question. No. Because we have actually other work within the project which I did not discuss. But what I discussed is a very local control, so it's specific. And when you're coming to system operation, there is not only local control, of course, because you need to make the different actors talk to each other, the different locations to talk to each other. And here there is a lot to work on, and especially when you're coming close to real time, you have in the real time operation of the system, you have really challenges on how quick things are done, on the reliability of data, and you really have also to combine really the information from the different stakeholders. For example, for us, if we have exchanges of energy between energy producers close to real time, system operators need to make sure it doesn't create any constraints on the grid. And then you have to mix the different information really close to real time, the grid and the energy producers and so on. And that's already it's still challenging, I would say.
Mm-hmm. Can I ask all of you a question on the digital twin? You know, this is, again, I'm also an electrical engineer originally, but if you hear the word digital twin, is there a focus theme within digital twin in terms of digitalization? Is there a key issue here, or is it just give me all the models of all the realities and in the end we have it? Is there something we need to do first there or so?
Yes, of course. You have a pain, or you have something you want to solve, and therefore you set up the digital twin. So at Interpreter, we are focusing for now to enable simple power flow analysis. That's is a simple electric model you can have. Of course, you can have sophisticated elements, but the next step is the question: Do we need dynamic models, or is for other analysis? But we already saw that a lot of topics can be covered by this static or quasi-static modeling. So this is a first step, and it's already challenging to get a good model of this. But we see that if you have this model, a lot of problems can be tackled already. So yeah, this is if we ask for all the information to set up a dynamic model, we would certainly not get to the end.
Yeah.
Have no results.
Yeah, I don't know if the others have here an opinion. on that.
I-
We need
It's
to
one comment.
learn about focus themes. We need to learn about what needs to be done first and what next and so on.
I would like to
I'm thinking of the distribution system, of course. The transmission system, they have their dynamic models, of course, but the difficulty is to get into the edge of the grid. Sorry to interrupt you.
maybe also giving floor to Monica to add to this discussion. And the follow-up question, Monica, after your response, I've noted in some projects, so there was in your project, Hans, I believe you've mentioned that you have very different distribution grids, some with 100% coverage of smart meters, some with 0 or none. And I think this is a very specific challenge of distribution networks that transmission networks are not facing. And historically, I'm also, by the way, a power systems electrical engineer. And I recall 20 years ago, you had SCADA, which covered about 10% of the distribution network. And you had to imagine using very different tools what's going on in the rest of the network. So I believe that the story of digital twin was driven a lot, not predominantly, but a lot by the needs of distribution systems, which don't have the budgets to put smart devices on everything, still to this day. So just a commentary again, but I would like to give the floor to Monica to add a few points here in general.
I agree with your view, Elena, and at the end it's an important condition, the type of grid you are looking at, the sources of data you have, and it's not only about having smart meters or conventional meters, which is obviously a key point, but it's also on the veracity of the data you can obtain, no? Because you might have smart meters, but you might have troubles or bottlenecks with the communication systems that allow gathering all this data being generated by smart meters. So at the end, with the smart meters, we have, let's say, benefits because they enable remote management, and this is positive for the operators and for the end users. And they also imply much more accuracy on the data we obtained from the energy system compared to traditional meters. But not everything is solved. We have still challenges on the type of data and on the, let's say, latency of this data, which is much more better than before, but we have still some challenges to address, maybe not related always directly to the smart meters, but to the surrounding systems we have around smart meters, okay? As I insist, for instance, one of the drawbacks we found is that some grids have smart meters installed, but we have some technical problems related to the power line communications systems that enable gathering this data, okay? And well, this is a little bit to contribute to this discussion around smart meters and to follow also on the digital twins. I think this is a quite very, let's say, common word we are using nowadays, but in fact there is not so much new in the sense of the aim of having a closer representation of what we are analyzing, no? Modeling energy systems or modeling what we aim at doing, and being able to capture how they behave in real time, okay? It's a very nice word, digital twin, and it's also, well, but we have to keep in mind that there's not so much new, no? We are following what we were doing in the past, but sometimes introducing new words to refer to what we want to do.
Yeah, can I hang in? Thanks. Yes, the electricity laws, Ohm's law, are the same today than I don't know, decades ago. And we just learn to model things in a better way, and because the computers get faster and so on. That's exactly my point. You know, we shouldn't keep the research community busy just because it's complex. You know, we need to move on to solve the real world issues, namely getting a system to run, you know, with very many renewables and very flexible loads and the right storage in between. You know, and yeah, I'm sometimes not sure if the electrical engineering and power system community, many of them are involved in these projects, you know, shouldn't look beyond the traditional and, for example, model consumer behavior. You know, digitalization and consumer has a lot to do. We are quite helpless, I think, in understanding how people act and react and what the feedback loop are and things like that. Isn't this an issue? You know, we work group 4 has the word customer or consumer in its header, besides the word digitalization. But in this session today, we heard much more about the DSO, TSO issues around digitalization. What do you say to that? Do we research? Of course, and I totally agree. This is key because the grid brings the things together, and the DSOs are those who do that. But in the end, we need to look at the key pieces which are changing, namely the consumers and citizens. And do we want them?
Yeah. And the markets, Rainer. Markets are changing along with them.
It's, for me, it's interesting. We were talking about sector coupling. Here we have the coupling of engineers and social science. That they typically are talking completely different languages. Also, another group of people which are different language with a different language are the market players. So yeah, that's interesting to bring together those. But on the other hand, I see also that at some point the automation of things in the end brings the real flexibility, recontrollability. We cannot depend on if I remember to program my my dishwasher or to switch off the lights, if it is not automated to some point, this is hard to get done. So that's my opinion from the electrical engineer. I think that if we have want to control something, we need some machine interface because the human interface fails too much. So,
yeah, that's good.
But yeah, this is would be interesting discussion between social scientists and engineers to get maybe some compromise. Some people say, "Oh, where's the freedom to switch on my dishwasher when I want to do it?" Maybe you have to put it just in between the storage, which decouples these things, and the storage does all the automatic control, while I can use my my home appliances when I want to. That, yeah.
We have 7 more minutes. Yes.
Sorry to interrupt you. We have 7 minutes to go.
Yeah, I would like to give the floor if anyone from the audience actually has the question for the panelists. To please post it in the chat or raise your hand and try to give us more flavor and more context here. And again, while we're waiting for the end of this session, after which we're going to go back to the main room and summarize all of these impressions, I would like to perhaps plant another, I would say, slightly provocative question for the audience here. Of course, the presentations today were chosen for the topic of monitoring, control, and interoperability. But since our last conversation was actually also around modeling consumers, first I would like to share with you that the Working Group 4 has actually worked on this topic as well. So no need to reinvent the wheel, as someone mentioned before. We have started working well on profiling different type of consumers, prosumers, and thereby different different type of consumers identified have very different type of behaviors and can be used in the simulation of consumption and how much they can add to the grid. So something that you can learn also more by joining the working group 4, but it will be part of the deliverables to come. And another question to everyone here, including Rainer, perhaps, our panelists and the audience. Why do you think that newcomers to the energy industry, such as big corporation, Google, Amazon, everybody who wants to join the story, are bypassing operators and trying to invent very user-friendly tools going directly towards the end customers? And why here in Europe, a lot of our research and innovation is still focused on the digital technologies?
Yes. Who wants to answer from the projects, please? Just feel free. We are recording here, but we are free. Does anybody want to answer from you?
It's a question to the audience as well. It's something that we can discuss, or we can just leave it hanging there as a question to everybody. I'm asking this because the name of the group is Digitalization and Customer Engagement, and we need to bridge the gap between, you know, hop over from the level of TSOs, DSOs down to the end customer, and then keep them in focus as well.
Yeah, I don't know if let me just start. I was employed at the university, then at the governmental office, which in the end created regulators. And why were regulators created in the field of electricity? Because grids are monopolies. You know, they are natural, so-called natural monopolies, according to the theory. There is no competition among grids. So there should only be one electrical grid in a community. This is at least today's common knowledge. It's not the same for communication. There we have parallel grids. And also for heat, providing heat, we have parallel paths to come with the heat. Well, it's actually discussable, but anyway, it's not a total, not natural monopoly. So I still think if you go to the consumer or customer, this guy thinks not in terms of natural monopoly. He thinks in terms of markets, probably, or incentives, or you know, all these classical people attitudes and things like that. But the grid is the monopoly, and we know they need to do a job. They have security and reliability in the headers of the law. They are mandated to do that. Security of supply. So we have this still the gap. Where is the market and where is, you know, the natural monopoly works? And I still think we have not really resolved, for example, the storage issues. You know, is this more on the consumer side or more on the grid side? We debate about it. And of course, as engineers, we say it needs both. Yeah, but anyway, these are the things, I think, which create this gap between what the new companies are doing. They just look for the business. They don't care about natural monopolies. They say they have their job, just solve it. So I stop here. But to me, this is not yet resolved. We still struggle with these roles in this changing world, I think.
Okay, if there are no comments from the audience, I need to stop here. So please raise your hand if you have any short, really 1 minute comment. Of course, we are still here. Otherwise, we move to the final session. No. Okay. Then thank you, Rainer. Thank you, Elena. Thank you all the project representative, but also the participants for your attendance here. And see you in 1 minute to the other session. You have the link on the access card, and also you receive it as Outlook invitation. Thank you very much.
Yeah, also thanks from my side, and also for sure from Elena's side, to all the 4 projects and the very interesting discussions. I think they helped us a little bit to advance. Thanks.
Thank you.
Thank you.
Thank you.
See you.
Thank you.